So, you guys sent us some really interesting stuff this time.
Yeah.
It's a video script and presentation slides, all about something called static testing,
Hmm.
specifically looking at something called reviews and inspections in software development.
Yeah, it's a fascinating area.
Yeah, so let's unpack this, right?
Let's do it.
Our mission today is to kind of really understand what static testing is, why it's so important in software development, and how these specific techniques, reviews, and inspections are really kind of fundamental to building better software, more robust software.
Sure.
And I think the compelling part is we're going to learn about how to do all this without actually writing or running a single line of code.
That's right, yeah.
So have you ever wished that you could spot problems in a big project before they happen?
Right.
Like, before they blow up in your face?
Absolutely, yeah.
This deep dive is going to show you how that's done in the world of software.
It's all about shifting left, as they say, finding problems early.
Shifting left.
Yeah, instead of waiting till the end and then try to fix everything when it's too late and too expensive.
Right. So kind of like I don't know, like a building inspector, right?
Yeah, exactly.
Like you want to make sure the foundation is solid before you start building the skyscraper.
Precisely, yeah. It's about checking the blueprints, the architecture,
Yeah.
before you start pouring concrete and putting up walls.
Right. So before you get too far down the road.
Yeah, exactly.
So let's define static testing. What is it?
So static testing, it's basically the process of carefully reviewing all those software artifacts.
Mm-hmm.
And that could be anything from, the initial requirements documents,
Right.
the design specifications, the code itself, the comments in the code, everything.
That's fair.
And we do all this without actually executing the code.
Mm-hmm.
The goal is to identify defects, ensure compliance with standards, and improve the overall quality of the software before it ever gets run.
Right. So you're not actually running the code. You're just looking at it. You're examining it.
Exactly.
Okay. That makes sense.
Yeah, and it's important to remember that this isn't just a one-time thing at the end of development. It's an ongoing process, integrated throughout the entire software development lifecycle.
Right.
We're talking about building quality in from the very beginning.
Gotcha. So, okay. So, that's static testing, right?
Yeah.
But why should you, the listener, find this relevant? Like,
Yeah.
why should someone who may not even be involved in software development care about static testing?
That's a great question. Think about it this way. Almost everything we do these days relies on software,
True.
right? The apps on your phone, your car, even your refrigerator.
Yeah, it's everywhere.
It's everywhere. And the quality of that software, how reliable it is, how secure it is directly impacted by practices like static testing.
Mm-hmm.
Even if you're not a developer, you benefit from better software.
So you're saying that even though we might not be the ones actually writing the code,
Yeah.
static testing still affects our lives because it leads to better quality software overall?
Exactly. It's about creating systems that are more reliable, more secure, and ultimately just work better.
Okay, so it has a real-world impact, even for non-programmers. That's a good point. So what are some of the concrete benefits, then, of using static testing?
Okay, well, first and foremost, static testing allows us to find defects early.
Okay.
And as we talked about, the earlier you find a bug, the easier and cheaper it is to fix.
Right, because you're not having to unravel a whole bunch of code to get to it.
Exactly. It's like finding a typo in a document before you've printed and sent it out to thousands of people.
Right.
You can just quickly fix it and move on.
Way easier to fix.
Much easier, right.
Okay.
Now, fixing errors early leads to another huge benefit, reduced costs. Studies show that fixing a defect after a software product has been released can be 10 times more expensive than fixing it during the design phase.
Wow, 10 times.
10 times, even more in some cases.
That's huge.
It's a massive difference. So finding those bugs early can save companies a lot of money.
Okay, so early detection means easier fixes, and that translates to big cost savings. What else? What other benefits?
So along with lower cost, you also get improved quality and reliability.
Mm-hmm.
When you catch bugs early, the final software product is just naturally going to be more stable, less prone to crashes, and generally more dependable.
Okay, so it's like building a house with a stronger foundation, basically.
Exactly. It's about building things right the first time.
Right.
Now, the fourth benefit is increased efficiency.
Okay.
When teams find and fix bugs early, they avoid those huge bottlenecks and rework cycles that can happen later in development. It means less time spent on firefighting and more time focused on building new features and improving the software.
Okay, so it streamlines the entire process.
Exactly.
Gotcha. So, we've talked about static testing as a broad concept, but now let's talk about those two techniques you mentioned before, reviews and inspections.
Yeah.
So how does fit into the picture?
Reviews and inspections are two of the most common and effective techniques for actually doing static testing. They are the tools we use to examine those software artifacts and find those potential problems.
Gotcha.
And they both really aim to find issues as early as possible in the development lifecycle.
Okay.
Now, there's a difference between a peer review, which is often less formal, and a formal inspection process.
So when we say peer reviewed, does that just mean like having a colleague look over your work?
Yeah, pretty much.
Right.
It's a way to get quick feedback from another set of eyes.
Right.
They can spot errors, suggest improvements, things like that.
Okay, so it's like a quick sanity check.
Yeah, exactly.
Okay.
Now, a formal inspection is a more structured process.
Okay.
It involves specific roles, checklists, and documentation. It's a more in-depth and systematic approach to finding defects.
So it's a much more rigorous process.
Yeah, definitely.
Okay, interesting. So we've got kind of two ends of a spectrum,
Right.
informal peer review on one end, and then a much more formal, structured inspection on the other.
Exactly.
But ultimately, both are trying to help you build better software.
Exactly.
Yeah.
And one of the key benefits of both approaches is that they improve communication and collaboration within the team.
That makes sense. The more you discuss and review each other's work,
Yeah,
the better you understand each other's thinking and the better the software becomes.
precisely.
Hmm.
It fosters a culture of quality and shared responsibility.
Right. So you're not just finding bugs, you're also building a stronger team.
Absolutely.
Okay, so let's dig a little deeper into those different review techniques.
Sure.
What are the main types of reviews that people use?
Well, we've already talked about the informal reviews or peer reviews,
Right.
which are great for quick feedback.
Yeah.
Another common technique is a walkthrough.
Okay, a walkthrough.
What's that? In a walkthrough, the author of the document or code actually presents it to the team,
Yeah.
kind of like giving a tour.
Okay.
It's an opportunity for them to explain their thinking and for the team to ask questions and provide feedback.
So it's a more interactive type of review.
Yeah, it's about understanding the rationale behind the decisions made.
Gotcha. And then we have those formal inspections,
Res-
which we've mentioned a couple of times.
Formal inspections are the most structured type of review. They involve specific roles, a very detailed examination of the document or code, and a strong focus on finding defects.
Okay.
They're really good at uncovering tricky bugs and ensuring compliance with standards.
So that's the most meticulous type of review.
Definitely.
Gotcha. And then finally, there are ad hoc reviews, right?
Yes, ad hoc reviews are those spontaneous checks that someone might do when they have a question or concern about a specific piece of code or documentation.
Okay.
It's not as formal or structured as the other methods, but it can still be helpful in catching potential issues.
So it's more of an on-the-fly check.
Yeah, exactly.
Okay, so you have a whole range of options depending on the situation and the level of rigor needed.
Exactly. You choose the technique that best fits your needs.
Gotcha. So let's dive a little deeper into that formal inspection process. Since it's the most structured, it seems like there would be a lot to unpack there.
Right. Formal inspections typically involve several distinct stages.
Okay.
First, you have the preparation stage.
Preparation.
In this stage, the team gets the document or code that will be inspected, and they get time to familiarize themselves with it.
Okay, so they're doing their homework, basically.
Exactly. They read it, they try to understand it, and they start thinking about potential issues.
Makes sense. So they're coming to the meeting prepared.
Yeah, preparation is key to a successful inspection.
Gotcha. What's next?
After preparation comes the overview meeting.
Okay, the overview meeting.
This is where the team gets together and discusses the document or code at a high level.
Okay.
The author usually gives a presentation explaining the purpose, the goals, and the overall structure of the artifact.
So they're providing context.
Exactly.
Yeah.
It helps everyone get on the same page before they start digging into the detail.
Makes sense. And then after the overview, I assume the real nitty-gritty work begins.
Yes, the next stage is the defect detection meeting.
Defect detection. Okay.
This is where the team really gets down to business, examining the document or code line by line.
So they're looking for errors, ambiguities, inconsistencies, things like that.
Exactly. They're looking for anything that could potentially cause a problem down the line.
Gotcha. And are they just kind of reading silently, or is there more to it?
Usually there's a designated reader who reads the document or code aloud.
Okay.
This helps keep everyone focused and ensures that nothing gets overlooked.
That's interesting. I can see how that would help maintain concentration.
Yeah, it's a very deliberate and focused process.
So they're carefully going through the material, looking for any potential issues. And what happens once they've identified these defects?
Well, that leads to the final stage, rework and follow-up.
Rework and follow up. Okay.
In this stage, the author takes all the defects that were found
Right.
and fixes them.
Okay.
And depending on how complex the changes are, there might be another review or even a second inspection to make sure that everything is correct.
So it's an iterative process.
Yeah, it's about making sure that the final product is as good as it can be.
Okay, that makes sense. So we've talked about the stages of a formal inspection, but who are all these people doing this work?
Right. In a formal inspection, there are typically 5 key roles.
5 roles. Okay, let's go through them.
Sure. First, you have the moderator.
The moderator.
This person is the leader of the inspection team. They're responsible for planning the inspection, making sure everyone follows the process, and keeping things on track.
So kind of like the project manager of the inspection?
Yeah, exactly.
Okay, who else?
Then you have the author.
The author.
This is the person who created the document or code being inspected. They're there to answer questions and explain their thinking.
So they're providing insights into how and why they did what they did.
Precisely. And they're also the one who's responsible for fixing any defects that are found.
Okay, makes sense. So we've got the moderator, the author, who else?
Next, you have the reader.
The reader. What do they do?
The reader is the one who reads the document or code aloud during the defect detection meeting.
Oh, right, to keep everyone focused.
Exactly.
Okay, interesting. Then what about documenting all the defects? Who handles that?
That's the recorder's job.
Recorder. Okay.
The recorder takes notes during the inspection, documenting all the defects that are found, any discussions, and the decisions that are made.
So they're creating a record of the entire process.
Exactly. And those notes are used later by the author to fix the defects.
Makes sense. Okay, so we've got the moderator, the author, the reader, the recorder.
And last but not least, you have the inspectors.
The inspectors. Okay, so those are the people who are really doing the in-depth analysis.
Exactly. The inspectors are the subject matter experts.
Okay.
They're the ones who really scrutinize the document or code, looking for potential problems.
Gotcha. So it's a whole team effort with each person playing a specific role.
Yeah, a well-coordinated team is essential for a successful inspection.
Okay, that's really helpful. So we've talked about the different roles and the different stages, but what are some best practices to make sure these reviews and inspections are really effective?
There are several key things to keep in mind. First of all, you need clear objectives.
Clear objectives.
Everyone on the team needs to understand what the goal of the review or inspection is.
Right.
Are you trying to find all the bugs, or are you focusing on specific types of errors?
Right. You need to know what you're looking for.
Exactly. Having that shared understanding from the start is really important.
So everyone's on the same page.
Yeah. And then you need well-defined roles.
Well-defined roles, so everyone knows their responsibilities.
Exactly.
Yeah.
When each team member understands their role and what's expected of them, the process runs much more smoothly.
Okay, so no confusion about who's doing what?
Right. And it also helps with accountability.
Gotcha. What else?
Another best practice is to keep the review focused.
Focused up.
Don't try to tackle every single issue at once. Prioritize the most critical defects and address those first.
So you're not getting bogged down in minor details.
Exactly. It's about being strategic and focusing on the biggest risks.
Okay, makes sense. Now, what about the people actually doing the reviewing? Do they need any special training?
Proper training is essential.
Okay.
You need to make sure that your reviewers understand the different techniques for static testing and that they know how to apply them effectively.
So it's not just about having a bunch of people look at something.
No, it's about having people who are skilled in the art of finding defects.
Right, so they know what to look for and how to look for it.
Exactly. Training can make a huge difference in the effectiveness of your reviews.
Okay, so clear objectives, well-defined roles, focused reviews, proper training, anything else?
The last best practice I'd highlight is defect tracking.
Defect tracking.
Okay. You need a system for documenting all the defects that are found, tracking their status, and making sure they get fixed.
So it's not just about finding the defects, it's about managing them and making sure they get resolved.
Exactly. And that data can also be used to analyze trends, identify areas where you need to improve your processes, and generally measure the effectiveness of your static testing efforts.
Right, so you're constantly learning and improving.
Absolutely. Continuous improvement is key.
Okay, so those are some really helpful best practices. But let's be real, implementing all of this probably isn't always easy.
You're right. There can definitely be challenges.
Yeah, so what are some of the common hurdles that teams face when trying to implement static testing?
Well, one of the biggest challenges is time.
Time.
Reviews, especially formal inspections, can take a lot of time.
Hmm.
And it can be hard to convince people to prioritize that time, especially when there are deadlines looming.
Yeah, it's always a balancing act.
It is. But it's important to remember that investing time in static testing up front can save you a lot of time and headaches down the road.
Right, it's like preventative maintenance.
Exactly.
Okay, what else?
Another challenge is human bias.
Human bias. Okay.
If the person reviewing the document or code is too familiar with it,
Mm-hmm.
they might miss errors that a fresh pair of eyes would catch.
Right, because they're seeing what they expect to see, not necessarily what's actually there.
Exactly. So it's important to try to get different perspectives on the review.
Okay, that makes sense. What about the people whose work is being reviewed?
Yeah, that can be tricky.
Yeah.
Sometimes people get defensive when their work is criticized.
Right. It's natural to feel a little bit protective of your work.
It is. And that can lead to resistance to feedback.
Resistance to feedback. Okay.
Yeah, it's important to create a culture where feedback is seen as constructive and helpful,
Mm-hmm.
not as a personal attack.
Right. It's about improving the product, not about pointing fingers.
Exactly.
Yeah.
And finally, another challenge is inadequate documentation.
Inadequate documentation.
Okay, if the requirements, design specifications, or the code itself are not well documented,
Mm-hmm.
it becomes much harder for reviewers to understand what's going on.
Right. They're kind of flying blind.
Yeah, and that can lead to missed errors and ambiguities.
So good documentation is crucial for effective static testing.
Absolutely.
Okay, so we've covered a lot of ground here.
We have.
To summarize, we've talked about the importance of static testing in software development. We've looked at the different types of reviews and inspections.
Yeah.
We've discussed best practices for making sure these reviews are effective.
Right.
And we've also looked at some of the challenges that teams might encounter.
Absolutely.
So if you had to boil it all down to like one key takeaway for our listeners,
Okay.
what would it be?
I think the most important takeaway is that static testing through reviews and inspections is a vital part of building high-quality software.
Okay.
By finding and fixing defects early in the development process, you save time, you save money, and you create a better product.
So it's all about shifting left.
Exactly. Find problems early, fix them early, and avoid bigger problems down the line.
Right, and it's not just about software either, is it?
No, these principles can be applied to any complex project,
Mm-hmm.
whether you're designing a building, planning an event, or writing a book.
Yeah, the idea of early detection and prevention applies across the board.
It does. It's about taking a proactive approach to quality.
I love it. So for our listeners out there, think about this.
Okay.
How much effort do you put into fixing problems after they've already happened?
Right.
And how could you apply these principles of static testing of reviews and inspections to your own work?
Yeah.
Could you build more quality into your projects from the beginning?
It's something to think about.
It is. It's a really powerful concept, the idea of preventing problems before they occur.
I agree.
Thanks for taking this deep dive with us.
It was my pleasure.